we will be finding the domain of a combined function. This function is a combination of a logarithmic and a rational expression. Log base 2 of x plus 1 over x minus 4 plus 1. In order for this function to exist, the argument, which is x plus 1 over x minus 4, must be greater than 0, as stated in here. In order to find where that rational expression is greater than 0, we draw the number line, use the root as x plus 1 equals 0, you get negative 1 as a root, and the restriction for x minus 4 not equal to 0, we get x equals 4, and that is representing a vertical asymptote. Now this function is positive in this interval. Since the root x equal minus 1 is an odd root, and x equals 4 is an odd restriction as well, therefore the sign will change and we have a positive, negative, positive. Reason why the sign starts here as positive, since the x plus 1 is a linear expression, linear expressions, or in general any linear expression with a positive slope, starts from quadrant 3, ends in quadrant 1. Therefore, the sign of that function as x goes to negative infinity is negative. Therefore, x plus 1, the same linear expression as x minus 4, starting from both quadrant 3, both having a negative sign, so negative over negative is positive. Hence, we have that positive sign here. Since the negative 1 root and the 4 as a restriction are odd restriction and root, therefore the sign will change. Now, finally, to find the domain, we're asking for where x plus 1 over x minus 4 is positive. It is positive for x is less than negative 1, and x is greater than 4. The second example, we'll look into the domain of function log base 3 of x squared minus 5x plus 6 over x plus 1 plus 1. Same ordeal, we have the x squared minus 5x plus 6 over x plus 1 is greater than 0. We factor the x squared minus 5x plus 6 into x minus 2 and x minus 3 over x plus 1. Again, we will do the number line, put the roots and the restrictions in order. Here we have only one restriction. The x equals negative 1, the other two are roots. All of them are odd, so the sign will change. Now here we're looking at the numerator being a quadratic equation, and quadratic equations with positive slope are going to start in quadrant 2 and end in quadrant 1. Therefore, we'll have a positive, as x goes to negative infinity, the function is positive, and in this quadrant, and as the x plus 1 is a linear, which starts in quadrant 3. So we have a positive over a negative, which makes a starting negative sign. And then we swap to positive, then negative, then positive, and as you see here, the domain exists between negative 1 and 2, and greater than 3. We cannot put or equal, because anytime we put or equal, we get a 0 value for the argument, or an indeterminate expression, which makes the log indeterminate.